Today we are taking notes on factoring by grouping to find zeros and solve. Our learning target today is that we can solve quadratic equations by factoring. When we want to find the zeros of quadratic functions, what we need to do is plug in 0 or substitute 0 for the y value or the f of x value, factor the quadratic, and then use the zero product property to set each factor equal to 0. And then the last step is to solve the simple equations to find the zeros. So let's look at example 1. We have f of x equals 2x squared plus 9x plus 10. So we'll take the f of x and make that into 0. So we'll have 0 equals 2x squared plus 9x plus 10. Okay, then we'll come over here, 2x squared times 10, it will give us 20x squared. And then we'll put our 9x here in the bottom of our factoring x. Okay, then we want to look at the factors of 20x squared. The factors will be 1x and 20x, 2x and 10x, 4x and 5x. So then we wanted to see which of these will add up to 9x, and that would be our 4x and 5x. So these will go in our factoring x. And we'll break that 9x apart into 4x plus 5x. So we now have 0 equals 2x squared plus 4x plus 5x instead of the 9x. We just broke that down into the plus 4x plus 5x and then bring down the plus 10. Okay, and then we'll factor by grouping. This is our first group, 2x squared plus 4x. This is our second group, 5x plus 10. So we'll factor out the GCF of the first group. 2x squared and 4x have a GCF of 2x, which leaves us with x plus 2 once we factor out the 2x. 5x plus 10, they have a GCF of 5, so we'll factor out a positive 5, which also leaves us with x plus 2. So this can be factored by grouping. We see that these both sides had an x plus 2 that was able to be factored out. So then I'll factor out that x plus 2 and see what's left over after I factor out the x plus 2 quantity from each term. So we will have 0 equals, so we're factoring out this x plus 2. Okay, and that leaves us with 2x and plus 5. Now, because of the zero product property, okay, and that's up there in our notes, we know that in order to equal 0, one or both of these terms, one or both of these quantities needs to be equal to 0. So let's go ahead and solve. Either x plus 2 is equal to 0. And I'm just going to kind of draw a line here. I don't want to rewrite this. I don't have a lot of space. So either x plus 2 equals 0 or 2x plus 5 equals 0. So just treat that as two separate smaller equations. So then I'll subtract 2 from each side here, which gives me x equals -2. Here, this is a two-step equation. So I need to subtract 5 from each side and then divide by 2 to get x equals -5/2. So x equals -5/2 and x equals -2. Okay, so that's where this quadratic will cross the x-axis. Okay, and that, oops, I forgot the negative right here on the 2. So that was a -2. Don't forget to add that in. Okay, moving on to number 2. Y equals x squared minus 3x minus 10. So we'll multiply the a and c terms. This will give us -10 x squared. We'll put the b term in the bottom of the x, -3x. And then we'll look at our factors of negative 10x squared. And we'll just ignore the negatives for a moment. So we can have 1x times 10x or 2x times 5x. Okay, and those are all the factors of 10x squared. Then I want to look at my middle term. So when I multiply the two numbers together, I get a negative. When I add them together, I get a negative. When I add them together, I get a negative. So if I multiply them together and it's negative, I know one has to be positive and one has to be negative. When I add them together, the sum is negative 3x. So because it's negative, I know that the larger absolute value has to be negative. Okay, so that means I would have negative 5x and positive 2x. So I'll go ahead and write those into my factoring x. And then I'll rewrite my quadratic with that middle term broken up into 2x and negative 5x. Y equals x squared plus 2x minus 5x minus 10. Okay, now I'll factor by grouping. X squared plus 2x is my first group. Negative 5x minus 10 is my second group. My first group only has a GCF of, we'll set this equal to 0 instead of y because we want to solve for the zeros. Sorry about that. Go ahead and change that y to a 0. And then we factor out the GCF for the first group, which is x. So we have x times the quantity, x plus 2. And then over here, we'll factor out the negative 5. Okay, negative 5x divided by negative 5 is positive x. Negative 10 divided by negative 5 is positive 2. Okay, so the GCF of these two terms is x plus 2. So if I factor again, I will get 0 equals the quantity x plus 2. Okay, what's left in my first term? I had x times the quantity x plus 2, and then I factored out the x plus 2. So what am I left with? The x. Okay, then I'm going to go to my second term, negative 5 times the quantity x plus 2. I factored out the quantity x plus 2. So this is now gone. What am I left with? Minus 5. So the factored form is 0 equals x plus 2 times the quantity x minus 5. And remember, you can check that by distributing. You can also check that with a graphing calculator or Desmos. Then the zero product property tells us, and I have a little more room, and these are both one step. So I'm going to just solve this a little differently than I did right here. So I know that 0 is equal to the quantity x plus 2 times the quantity x minus 5. So in order to be equal to 0, one or both of these quantities has to be equal to 0. 0 times anything equals 0. So I'll branch these off into the two different possibilities. Either x plus 2 equals 0 or x minus 5 equals 0. Okay, and that's just a little bit cleaner looking than what I did on number 1. So then I'll subtract 2 from each side to get x equals negative 2. And then I'll add 5 to each side to get x equals 5. So my solutions are x equals negative 2 and x equals 5. Moving on to number 3. So I'll say 0 equals, okay, make my factoring x over here. Negative 3x squared times positive 4 gives me negative 12x squared. And my middle term is positive 4x. So this goes here in the bottom of the factoring x. Then I'll list all the different possible factors of negative 12x squared. I'm going to ignore the x or the negative for a moment. So 1x and 12x, 2x and 6x, 3x and 4x. Okay, next. I'll break that. So then we want to see which of these, we have a negative answer. So in order to have a negative, negative product, one number has to be multiplied, has to be negative, and one number multiplied has to be positive. And then our sum, when we add them together, is a positive 4x. So that tells us that there were more positives than negatives. So these values in the right-hand column are the positive choices. These values in the left-hand column are the negatives. So which of these pairs adds up to positive 4x? Right here, the negative 2x plus 6x will add up to the positive 4x. Okay. Negative 1x plus 12x would give us 11x, so that's not correct. 4x minus 3x would give us 1x, so that's not correct. All right, so again, we decided that the negative 2x and the positive 6x is what we're going to break this 4x into. So we have 0 equals negative 3x squared minus 2x plus 6x plus 4. And then we'll go ahead and factor by grouping. That's our first group. That's our second group. So we have 0 equals. Then I look at the first group, I want to factor out the negative, and I want to factor out an x. So negative x. And then what that leaves me with is, so I had a negative 3x squared divided by negative x. That leaves me with a positive 3x. And then I had a negative 2x, and I factored out a negative x, so that leaves me with a positive 2. So 3x plus 2. Then I come over here to my second group. I see 6x plus 4. That has a GCF of 2. 6x divided by 2 is 3x. 4 divided by 2 is 2. And then I see they both have the factor, when I factored out the by group, each of them had the 3x plus 2 quantity, which is great. So I know I'm on the right track. Bring down the 0 equals. Now between these two terms, remember the two terms are separated by a plus sign. Now we're going to factor again, and we're factoring out the quantity 3x plus 2. That's the greatest thing they have in common. So again, this is a new equation. Now we're factoring out a GCF. Okay, so here our GCF is 3x plus 2, and then we factor out negative x plus 2. All right, so this leaves us with 0 equals the quantity 3x plus 2 times the quantity negative x plus 2. Then using the 0 product property, I know that 3x plus 2 can be equal to 0, and negative x plus 2 is equal to 0. Subtract is equal to 0. I forgot that 0 there. Subtract 2 from each side, which gives us 3x equals negative 2. Divide each side by 3. So this gives us x equals negative 2/3 here. Subtract 2 from each side. This gives us negative x equals negative 2. Divide each side by negative 1, which gives us x equals 2. So x equals negative 2/3 and x equals 2. All right. Number 4. We'll set this equal to 0. Take our factoring x and we'll make it over here. X squared times 15 gives us 15 x squared. Our middle term is minus 8x. Let's list our factors of 15x squared. And again, if you can do this in your head and you don't need to list the factors, I'm okay with that. But I'll always show the work so you know where I'm getting my values from. Okay, some of you don't need this t-chart over here and you're doing it in your head, and that's awesome. Okay, so 1x and 15x, 3x, and 5x. When I multiply them together, they gave me positive 15x. When I added them together, they gave me negative 8x. So in order to multiply together to a positive number, they're either both positives or they're both negatives. To add up to a negative, They both have to be negative. So we know we're looking at all negative values. Okay. And then which of these two pairs add up to negative 8x, negative 3x, and negative 5x? Negative 3x and negative 5x. So now I'll rewrite my equation. I'm going to slide this to the left a little bit. X squared minus 3x minus 5x plus 15. All right, then I'll factor by grouping. So 0 equals, that's my first group. That's my second group. So when I look at my first group, they have a GCF of x. So I'll factor out an x. And I look at my second group, they have a GCF of -5. So I'll factor out a -5, which leaves me with -5x divided by -5 is positive x. Positive 15 divided by -5 is -3. So there's my x minus 3 quantity in both terms. So I can factor that out. 0 equals the quantity x minus 3. And then what's left over in this one? The first term, x times the quantity x minus 3. I factored out x minus 3, so that leaves me with x. In my second term, once I factored out the x minus 3, it leaves me with -5 or -5. Okay, then I have two options, either x minus 3 equals 0 or x minus 5 equals 0. Add 3 to each side to get x equals 3. Add 5 to each side to get x equals 5. Okay, so x equals 3 and x equals 5. Okay, number 5. Okay, 0 equals a times c gives us 6x squared. My middle term is -7x. So my factors are 1x and 6x, 2x, and 3x. All right, so then I want to take a look at the signs. When they multiply together, they give me a positive 6x. When they add together, they give me a -7x. So that means they both have to be negative. And then which of these pairs adds up to -7x? That's the -x and the -6x. So then we rewrite the equation. 0 equals, and I'm sorry, I'm going to start farther to the left again so I don't run out of space. 0 equals x squared minus 1x minus 6x. And then bring down the plus 6. Then we can factor by group. Okay, my first group, the GCF is x, so 0 equals x times the quantity x minus 1. And the second group, my GCF is -6, so -6 times the quantity, so it's -6x divided by -6 is positive x. Positive 6 divided by -6 is -1. Okay, so we have the x minus 1 quantity that's common in both terms, so we know we factored correctly by group. Now we'll factor out that GCF of the quantity x minus 1. So 0 equals the quantity x minus 1 times the quantity x minus 6. And we branch that off using the zero product property. Either x minus 1 equals 0 or x minus 6 equals 0. Add 1 to each side to give us x equals 1. Add 6 to each side to give us x equals 6. So x equals 1 and x equals 6. All right, and then number 6. Y equals 4x squared minus 3x minus 1. So we'll rewrite that as 0 equals, okay, and then we'll make our factoring x. 4x squared times -1 gives us -4x squared. Our c term is -3x. Okay, so negative 4x squared. Let's look at the factors of that. Come back to the negative sign in just a moment. We can have 1x times 4x or 2x times 2x. When they're multiplied together, they gave us a negative. When they added together, they gave us a negative. So to multiply together to get a negative, one number has to be positive, one number has to be negative. To add up to a negative, the number with a larger absolute value had to be negative. So that means that the right-hand column are the negative values, or holds the negative values. So this will give us a sum of negative 3x. Positive 1x minus 4x equals negative 3x. So these are our two terms, 1x and negative 4x. So then we break that apart. 0 equals 4x squared plus 1x minus 4x minus 1. And then we factor by grouping. 0 equals 4. Oops, sorry. I was copying that down again. So then our first group, 4x squared and x, they have a GCF of just x. 4x squared divided by x is 4x. X divided by x is 1. So 4x plus 1. And then over here, negative 4x and minus 1, we're just factoring out a negative 1. Okay, and then negative 4x divided by negative 1 is positive 4x. Negative 1 divided by negative 1 is positive 1 or plus 1. Okay, then we look at our two terms. They have a GCF of 4x plus 1. So 0 equals 4x plus 1. And what's left over when I factor out x and minus 1? So x minus 1. Okay, then they have a product of 0. So using the 0 product property, I branch this off into the two possible scenarios that will give me a product of 0. So either 4x plus 1 equals 0, or x minus 1 equals 0. Add 1 to each side to get x equals 1. Subtract 1 from each side. And then divide by 4 to get x equals negative 1/4. So x equals negative 1/4 and x equals 1. Okay, turn the page over. Okay, so now we're looking at some examples that are not simplified yet. So solving quadratic equations using factoring, we want to set so these equations on the front page were all nicely set equal to y for us, or set equal to f of x for us. On the back page, or the second page, it's not all nice and organized for us, so we need to set it equal to 0. So we need to combine like terms, get all of our values of all of our x values and constants on one side and set it equal to 0, and then factor by grouping. So this is very similar to what we did on the front of the practice sheet or the notes sheet, except now we have to combine like terms, get all of our x squared terms, x terms, and constants on one side and set it equal to 0. All right, so I like my leading coefficient. Personally, I like my leading coefficient to be positive. So I look at the x squared first. This is 2x squared, that's x squared. If I want my x squared term to be positive, there are more on the left side, 2x squared, than there are on the right side, 1x squared. So I'm gonna leave this one here and subtract x squared from each side. Okay, and then we can do this one step at a time on this first equation, but after this first one, I'll probably combine steps just to save rewriting so many times. Okay, so 2x squared minus x squared gives us x squared. Bring down the plus 4x minus 5. bring down the equals. X squared minus x squared is 0, bring down the 10x plus 7. Okay, so now I want all of the x's on the same side. So the goal is to get 0 on the right-hand side and all of the other terms on the left-hand side. So subtract 10x from each side. This gives me x squared minus 6x minus 5 equals 10x minus 10x is 0. Bring down the 7. Subtract 7 from each side to get x squared minus 6x minus 12 equals 0. Okay, so again, you can see I did that step by step by step. What I'm going to do on the rest of these is just combine those into maybe 1 or 2 steps. So that way I'm not taking up all the space. Okay, and then I'm going to go ahead and look at my a times c. So x squared times negative 12 gives me negative 12x. My middle term is minus 6x. Oops, this is minus 12x squared, excuse me. So then I'll look at the negative 12x squared. This can give us 1x. The factors are 1x and 12x, 2x and 6x, 3x and 4x. And then I want to see which of these will add up to negative 6x and multiply to negative 12x squared. So to multiply to a negative, we have to have one positive, one negative. To add up to a negative, there needs to be a larger negative absolute value, which means these numbers in the right-hand column would be the negatives. Negative or positive 1x minus 12x is negative 11x, not negative 6x. So that doesn't work. 2x minus 6x is negative 4x, not negative 6x, so that doesn't work. 3x minus 4x is negative x, not negative 6x. So none of these factors work to multiply together to give us negative 12x squared and add together to give us negative 6x squared. So since none of these factors work in our scenario, this cannot be factored. Okay, so it cannot be factored. And we will learn another method of solving quadratics that aren't factorable, and that's going to be called the quadratic formula. We're saving that for last. Okay. So we'll pause for a question in the room. Okay, moving on to number 8, we have 3x squared minus 4x minus 10 equals 2x squared minus 4x plus 15. And we want to find the zeros. So we want to start off by combining like terms and setting the equation equal to 0. So I'll subtract 2x squared from each side. Okay, and then I want this side to be the side that has the 0. I just want my leading coefficient to be positive. So then I'll add 4x to each side. And I'll subtract 15 from each side. So on the right-hand side, 2x squared minus 2x squared is 0. Negative 4x plus 4x is 0. 15 minus 15 is 0. So on the right-hand side, I have 0. And the left-hand side, 3x squared minus 2x is x squared. Negative 4x plus 4x is 0, so that cancels out. And negative 10 minus 15 is minus 25. So we have x squared minus 25 equals 0. So when I do a times c, remember what's my middle term? 0x. So if you wanted to write a plus 0x here in the middle, x squared plus 0x minus 25 equals 0, you could. Okay, so there's a plus 0x here in the middle. The b term is 0. Okay, so when I make my factoring x, a times c gives me negative 25. Oops, I wrote negative 55, I'm sorry. Negative 25 x squared, and my c term, or excuse me, my middle term is 0x, okay? Because there's no b term in the middle. Okay, so let's look at our factors of negative 25x squared. I can have 1x and 25x, or 5x and 5x, to add up to 0 and multiply to a negative. Okay, just one of them has to be negative. It'll be plus 5x and minus 5x. Okay, so then I rewrite it as, so I can factor by grouping x squared plus 5x minus 5x minus 25 equals 0. And again, you'll start to recognize these. This will be the, the quantity x plus 5 times the quantity x minus 5 equals 0, giving you the values, the x-intercepts at x equals 5 and x equals negative 5. You'll start to be able to do these in your head, but I'm showing you all the steps so you can solve it every time algebraically, no matter what. Okay, so now we'll factor by grouping. And we'll factor out in our first group just x. So x times the quantity x plus 5. In our second group, we'll factor out negative 5, which leaves us with x, because negative 5x divided by negative 5 is just x. Negative 25 divided by negative 5 is plus 5. Bring down the equals 0. Okay, now here's our first term, x times the quantity x plus 5. Here's our second term, negative 5 times the quantity x plus 5. They obviously have in common the quantity x plus 5, so we'll factor that out. That leaves us with the quantity x minus 5. Bring down the equals 0. Then we use the 0 product property to set these both equal to 0. Either x plus 5 equals 0 or x minus 5 equals 0. These are both just one-step equations. So x equals negative 5, add 5 to each side, x equals positive 5. So our zeros are, our x-intercepts are x equals negative 5 and x equals positive 5. Okay, and you will get to the point where as soon as you see this, x squared minus 25, okay, you'll know these are perfect squares. It has a negative, so that's going to factor into the quantity x plus 5 times the quantity x minus 5, which is going to give you the zeros at x equals 5 and x equals negative 5. Okay, and then I'm okay with you skipping all of this factoring and that you just memorize that. Okay, these are, it's a perfect square trinomial. So if you go right from here to here, I'm okay with that. Okay, I do want you to understand the process. To be able to prove it algebraically is important, but memorizing this and going from here to here is just a realistic time saver. Okay, it's a perfect square trinomial. Okay, number 9. 4x squared plus 2 equals 2x squared plus 3x plus 7. I like to have all of my leading coefficient positive, so I'm going to subtract 2x from each side. Oops, 2x squared, excuse me. So this, and then I will subtract 3x from each side. I just wrote that up here. And subtract 7 from each side. Bring down the equal sign. On the right side, we have 2x squared minus 2x squared, that's 0. 3x minus 3x, that's 0. 7 minus 7, that's 0. So my right side equals 0. I'm just going to slide that over a little bit for some more room to work on the left. Okay, on the left, 4x squared minus 2x squared gives us 2x squared. Here's my minus 3x. Then I have plus 2 minus 7, so 2 minus 7 is minus 5. So I have 2x squared minus 3x minus 5 equals 0. Okay, so then I can go ahead and get my factoring x over here. A times c is negative 10x squared. My middle term, my b term is negative 3x. Okay, so let's look at the factors of negative 10x squared. We'll come back to the negative in a moment. So 1x times 10x would give me 10x squared. 2x times 5x would give me 10x squared. So when I multiply them together, that gives me a negative. They give me a negative. So I know I'm multiplying one positive and one negative. When I add them together, I get a negative. So I know the larger absolute value is the negative value. And then I want to see which of these will add up to negative 3x. Well, that's going to be the 2x minus 5x. So 2x minus 5x, or negative 5x. So I'll break that middle term up. This will be 2x squared. The middle term, I'm going to break that up into negative 3x, from negative 3x into 2x minus 5x. Bring down the minus 5, bring down the equals 0. Okay. Then I'll factor out the GCF. Here, my GCF is 2x, which leaves me with x plus 1. Okay, here I'm going, my GCF is negative 5, which leaves me with positive x plus 1. Bring down the equals 0. Okay, I see they have a GCF of the quantity x plus 1. So x plus 1 is factored out. And then what am I left with after I factor out the x plus 1 from each term? The first term has a 2x left, and the second term has a minus 5. Bring down the equals 0. Use the zero product property to branch this off into the two possible solutions. X plus 1 equals 0, and 2x minus 5 equals 0. Subtract 1 from each side to get x equals negative 1. Add 5 to each side to get 2x equals 5. Divide each side by 2 to get x equals 2/5. So x equals 1, or excuse me, 5/2. So x equals negative 1 and x equals 5/2. And moving on to number 10. (3x minus 2 equals x squared minus 4x plus 10). So my leading coefficient is the x squared. It's only on the right-hand side, and it's already positive. So my preference is to just leave it where it is. So I will have my 0 on the left-hand side for this problem. I will subtract 3x from each side and add 2 to each side. 3x minus 3x is 0. Negative 2 plus 2 is 0. So this leaves me with 0 equals x squared minus 7x plus 12. A times c will give me 12x squared. My b term is negative 7x. So then I'll look at all the different possible factors of 12x squared. That'll be 1x and 12x, 2x and 6x, 3x and 4x. So they need to multiply together to give me a positive and add together to give me a negative. So when I think about that, to multiply together to get a positive, it's either positive times a positive or negative times a negative. But to add together to be a negative, we have to have at least one negative. So in this case, they have to all be negatives. Okay, because they're multiplied together to give us a positive. And when we add them together, they add up to a negative. So all of them are negatives. All right, and then we want to see which of these pairs of factors add up to negative 7x. Not the top pair. Negative 1x minus 12x would be negative 13x. That does not add up to negative 7x. Not the middle pair, because negative 2x minus 6x would give us negative 8x. It is the last pair. Negative 3x minus 4x does add up to negative 7x. Okay, so the two other sides of our x are negative 3x and negative 4x. Okay, so now I'll take that middle term, the minus 7x, and I'll break that up into minus 3x minus 4x. Okay, so 0 equals x squared, and instead of saying minus 7x, we're just going to rewrite that as minus 3x minus 4x, because negative 3x plus negative 4x is the same as negative 7x. And then bring down the plus 12. Okay, then we'll factor by grouping. Here's our first group. Here's our second group. Bring down the 0 equals. What's the GCF of x squared and negative 3x? X. So I'm factoring out an x. X squared divided by x is x. Negative 3x divided by x is negative 3. Okay, then I look at negative 4x plus 12. What's the GCF? Negative 4. I'm going to factor out that negative. What's negative 4x divided by negative 4? Positive x. What's positive 12 divided by negative 4? Negative 3. These two, after I factored out the GCF, I have the x minus 3, the x minus 3. So I know I'm doing my factoring by grouping correctly. So now I do one more round of factoring. Remember, here's the first term. X times the quantity x minus 3, separated by the minus sign. Here's our second term. What did they have in common? X minus 3, the quantity x minus 3. So 0 equals. So now I'm factoring out of this group and this group, okay? So x, or not this group and this group, this term and this term. X minus 3, okay? So what's x times the quantity x minus 3 divided by x minus 3? The x, okay? And then what's, if I have negative 4 times the quantity x minus 3, I factored out the x minus 3, what do I have left? The minus 4. Okay, so then we have, with the 0 product property, either x minus 3 equals 0 or x minus 4 equals 0, because they have a product of 0. Okay, add 3 to each side. Add 4 to each side for that one. Okay, and our zeros are x equals 3 and x equals 4. Okay, so this parabola will cross the x-axis at 3 and at 4. Okay, so that's solving quadratic equations using factoring by grouping.